Hello, everyone, and welcome. First of all, I'd like to thank you for attending our webinar today. My name is Koji Yamamoto, and I am a developer of Multiscale sim at Cybernet Systems. Multiscale sim is our original software to realize multiscale analysis. Cybernet is a software solution partner of Cortex System. We are working closely with them to develop integrated solution workflows between Moldex 3D and Multiscale sim. We have held 2 webinars with Cortex so far. The topic was the same as today's regarding cooperation with Moldex 3D. In each webinar, I focused on structural analysis of the product made by injection molding or resin transfer molding. Today, I will talk more about the mechanism of tool collaboration and its unique benefits. So here is the agenda of today's presentation. First of all, I would like to talk about the basics of multiscale analysis. I'd like you to understand why multiscale analysis is necessary for performance evaluation of the resin-molded products. I then provide the slightly more specific theoretical explanation in the next topic. The important point of this tool is how we can estimate accurately the material constants of the composites in short time. Finally, I will demonstrate the product. I will introduce the general operating procedure for predicting the anisotropic material constants from the heterogeneous microstructure of composites. Okay, so let's move on to the first topic, which is why multiscale analysis is needed. Let me briefly introduce the molding process for composites. I'm sure many of you may already know about this, but please bear with me. Unlike metals, composites are manufactured and molded at the same time, so there are many different molding methods depending on the application. As shown in this graph, it is said that there is a trade-off relationship between the performance and the productivity. Autoclaving is a method which can obtain the highest quality. Thermosetting resin prepreg is formed into the predetermined shape and heated in the pressurized container. It is particularly effective for parts that require high reliability, but productivity is poor. In recent years, RTM is attracting attention as a method that can increase productivity while maintaining the strength. In this method, FRP is manufactured by shaping dry fabric into the desired shape and then pouring resin into it. It is also unique in that it can be made from reusable thermoplastic resin, which reduces environmental impact.